Alright everyone, you should have already taken these notes. This was that purple sheet of paper that you were asked to fill out after the test. So if you haven't done that, make sure after you watch the notes that you're about to do, that you then grab that purple sheet of paper, which is in the bin, and fill this out. So this is the properties of all the parallelograms that we're going to use this unit. It's going to go through and talk about what a parallelogram is, what all the properties are, and then it's going to go through the special types of parallelograms, which are a rectangle and what those properties are, and then another special parallelogram, which is a rhombus, and what those properties are, and then a square and what those properties are. Okay? So what this unit is talking about is what makes a four-sided figure a parallelogram and what makes a parallelogram these other types of figures. Okay, but we're going to start with parallelogram first. Alright, so your objective is that you can identify the properties of parallelograms and that you can apply the 5 properties of parallelograms. Okay, so just parallelograms is what we're focusing on. Okay, so to start off with, let's talk about what it means to be a polygon. A polygon is a figure with all straight sides. Can't have any curved sides, so like a circle is not a polygon. A polygon also has all sides connected. So an example of a polygon would just be something like that. So all straight sides, 4 sides, polygon. Okay. A quadrilateral, quad, is a 4-sided polygon. So the most common polygon that we probably think of is a rectangle or square. Alright. And then a parallelogram is a specific type of quadrilateral. The definition of there's a lot of properties of a parallelogram, but the definition of a parallelogram is that it is a quadrilateral that has opposite sides parallel. Okay, so that is the definition of a parallelogram. It's easiest to remember because it's parallel in the word. So, parallelogram looks like this. So there's a 4-sided polygon where the opposite sides are parallel to one another. So the left and the right are parallel, and the top and the bottom are parallel. When that happens, you get 4 additional properties with it. Okay? So, one of the properties is that opposite sides are congruent. So if you have a parallelogram, then the opposite sides are congruent. So that means that segment AB and DC are congruent. So AB is congruent to segment DC. Okay? That also means that segment AD and BC are congruent. So segment AD is congruent to segment BC. Alright, so all of these are for parallelogram A, B, C, D. And remember, anytime that we call something a figure, we must always go from point to point to point, point, and then back up. So we can never call this figure A, C, D, B, or something like that, because we can't go across my figure. As soon as I name one point, I have to go either clockwise around the figure or counterclockwise around the figure. Okay? Alright. Another property. So if quadrilateral ABCD is a parallelogram, not only are opposite sides congruent, but opposite angles are congruent as well. So that would mean that angle A and C are congruent. So label your figure as well. That also means that angle B and D are congruent. So angle B would be congruent to angle, congruent to angle D. Alright, another property. So if quadrilateral ABCD is a parallelogram as shown, then consecutive angles are supplementary. Okay, so what that means, consecutive means one right after the other. So if we start at A, the next angle would either be B, or I could go backwards and go to D. So that means that angle A plus angle B equals 180 for supplementary. Or I could say angle B plus angle C equals 180. So any angle I choose, I could go forwards and backwards. For instance, I could say angle D, and then I could either go forwards to angle A and say that those two together are 180, or I could go the other way from D and say that angle D plus angle C equal 180. And then there's other combinations that I can do as well. Okay? Alright, last one. If quadrilateral ABCD is a parallelogram, then the last property is that diagonals bisect each other. This is probably the property that's most forgotten. So if I were to draw in my diagonals, because I have none right now, that means that I would go from A to C, and that means that I would go from B to D. So just like this. If I could draw it better. But if they bisect each other, that means that segment BD just bisected AC, which means it made those two congruent. That also means that AC bisected BD, which makes those two congruent. So that means that I could call this intersection point E. That means that I would say segment AE is congruent to segment EC. I could also say that segment BE is congruent to segment ED. Okay? Flip over your paper. So let's sum up what we just realized. So, the very first property is that if a quadrilateral is a parallelogram, then opposite sides are parallel. Okay, that is the definition of a parallelogram. Because that is true, you now get 4 additional properties. One of them is that opposite sides are congruent. One of them is that opposite angles are congruent. One of them is that consecutive angles are supplementary. And the last one is that diagonals bisect each other. And this all happens if parallel. So if opposite angles are, or opposite sides are parallel. Okay. So let's kind of put some of this to work. Okay, if I have parallelogram GOLF, so off to the right, segment OS be here, that segment is congruent to segment FS because diagonals bisect each other. Okay, so that means, just to draw in this, means this segment is congruent to this one, and this one are congruent to that one, because of diagonals bisecting each other. Angle OGF, would be this angle. Remember, opposite angles are congruent, so that angle would be congruent to this angle. And that angle you could call two names. You could either say angle FLO, or you can go the other way and say angle OLF. Okay? angle OGF, which is again this angle, is supplementary to either that angle or I could go backwards to that angle. So I'm just going to write one. And I'm going to say angle GOL. Remember, do not say angle O. That angle doesn't exist. Alright. Triangle GSO. So triangle Triangle GSO would be this triangle. That triangle is congruent to this triangle by a lot of different properties, but one of them would be side angle side because, side angle side because of vertical angles. I just have to make sure that I say it in the right order, which is the hardest part. So GSO would be congruent to LSF. LSF, and that's the only way that I can say that triangle. GF, clean up my figure so you guys can see a little bit better. Okay. This segment right here is parallel to this segment over here. GO, this segment, is congruent to its opposite side. FL. Angle OGL, which is this angle right here. Okay, remember that OGL means that if you follow the sides, you'd be like this, which then means this angle. So that angle is actually congruent to this angle right here. And the reason is if I extend this, you guys should be able to see that this is a transversal because of parallel sides, and opposite or alternate interior angles are congruent. So parallel lines cut by a transversal means those are alternate interior angles. So I would say angle. One way to name that angle would be angle FLS. Okay? Alright. Given these two parallelograms, find all missing angles. So I know that opposite angles are congruent, so this angle would have to be 47. I know that these two angles are supplementary, so 180 minus 47 gives me 133, and opposite angles are congruent. If I added all of those up, so if I said 2 times 133, because there's two of them, plus 2 times 47, I would get 360 degrees, because quadrilaterals have four angles that sum to be 360. Okay? And the next one, opposite angles are congruent. These two angles are supplementary, so 180 minus 108, this angle is 72, which means this angle is 72 as well. Alright, next one. Okay. Find the missing coordinates of parallelogram WXYZ. So there's 4 points. This is a parallelogram. We are only given 3 of them. We need to find the 4th. So plot your points. Label your points. So we know that this is W, this is X, and this is Z. So remember, everything must go in order. So we're told WXYZ is our parallelogram. So WX, we're missing our Y coordinate. So if we're missing our Y coordinate, we go from W to X, and then we must go to something to Z to here, and we can kind of say that that's our figure. So I'm going to erase this because we should be drawing this in, but so let me show you then what you should be doing. If we understand that opposite sides are parallel, that means that I know my coordinate is somewhere over here. So if I look at from W to X, I go up 1, 2, 3, 4, 5 over 1. So my slope is 5 over 1, which means then the slope from Z to my Y has to be the same thing. So if I go up 1, 2, 3, 4, 5 over 1, I can see my points right here. If I connect those, I can now see that those segments are parallel. They have the same slope that way. And these segments, WX and YZ, are parallel as well because they have the same slope. So my coordinate of Y is 6. Okay. Alright, flip it over. Okay. Number 10. Using the properties of a parallelogram, we're told that this figure is a parallelogram. We want to find the perimeter. Okay, remember, perimeter is the distance around the figure. So I need to figure out how far it is to go from E to W to T to N back to E. So opposite sides are congruent, so this side's 11. Opposite sides are congruent, so this side's 15.4. So my perimeter is equal to, I can add them all up, or I could say 2 11s plus 2 15.4s. When I add those up, I find that my perimeter is 52.8 centimeters. Make sure you include your units. Okay. The next figure, I'm told again that this is a parallelogram, which means all those properties apply. There's 5 of them. Find the perimeter. Okay, so I need to find the distance around my figure. So you can see that I need to find the length of segment GP, RO, and those two, because I know that the top and bottom are 9. But by knowing that the top is 9 and the bottom, this portion, I'm telling you that this right here is 6. So if I know that's 6, then this has to be 3, because that whole segment's got to be 9. Okay? And then this is something that's been coming up on a lot of PBTs that nobody's been asking about. So let me explain it now. This is a right triangle. If I want to find if I want to find a side of the right triangle, all I really need are 2 sides. Okay, Pythagorean theorem. Let me just draw it over here real quick. Pythagorean theorem says that when you have a leg and a leg, if you square them, it's equal to your hypotenuse squared. So Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Your A and your B don't matter which one you call which, but if you square them and add them together, it's equal to your hypotenuse. You must always set it equal to your hypotenuse. Okay? So in this case, we're finding our hypotenuse, so I'm going to call this X. Or actually, I'm going to call it C because it's my hypotenuse. Oops. So I'm going to say 3 squared plus 4 squared equals C squared. So 9 plus 16 equals C squared. So 25 equals C squared. I want to find C. I take the square root. That's what undersquaring. Square root of 25 is 5. So that means that this side is 5, which makes this side 5. So my perimeter is equal to the top and bottom are 9, so 2 9s. And the left and right are 5, so 2 5s. Which means my perimeter is 28 feet. Okay, and the reason I could do that is because of properties of parallelograms as well as understanding Pythagorean theorem. Okay, and that only works for right triangles. Okay, 12, 13, and 14 are all going to ask you to determine if the figure is a parallelogram. So you're given 4 vertices, which means the figure must be a quadrilateral. And then you're asked to determine if it's a parallelogram. Well, if you're in number 12, you're asked to use slope to determine if the figure is a parallelogram. So what you should be thinking is, how can slope help me to determine if a 4-sided figure is a parallelogram? Well, slope can help me determine if the opposite sides are parallel, and if they are, then the figure is a parallelogram. So what I would do is I would draw out my figure. If I'm told A, B, C, D in that order, I'm going to say A, B, C, D. The letters don't matter where you put them, as long as wherever you start, you go in a circular manner, meaning I could call that my figure, or I could rotate them and I could say A, B, C, D. Okay? It does not matter which way you name them. I'm going to leave it like that. Okay? So, using slope to determine means that I want to know, right over here, are opposite sides parallel? If they are, my figure is a parallelogram. If they're not, my figure is not a parallelogram. So my opposite sides for what I've drawn in, which should be the same as yours, and it doesn't matter how you draw it, my opposite sides would be CD parallel to AB, or our top and bottom parallel, CB parallel to DA, and both of these must be parallel. So what I'm going to do is I'm going to go find those slopes. So I'm going to say the slope of CD, and I'm actually going to write all this out before I do math. I need to find the slope of AB. I need to find the slope of CB. And I need to find the slope of DA. So I'm finding the slope of all my lines. Alright, and given the fact that I have vertices, I'm just going to use my slope formula. So right now I'm looking at C and D, so these two coordinates. So change in y over change in x. So 7 minus 1 over 5 minus 3. And now I'm looking at AB. So these two. So my y's would be 0 minus 6 over 0 minus 2. I'm going to change again. So now I'm looking at CB, which are here and here. So my y's would be 6 minus 7 over 2 minus 5. Alright, I'm going to switch again. And I'm going to look at a DA, so first and last. So my y's are 0 and 1, so 0 minus 1, and my x's are 0 and 3. Alright, so simplify. So this gives me 6 over 2, which is 3. This gives me negative 6 over negative 2, which gives me 3. So those two are the same, so that's good. Those are parallel. This gives me negative 1 over negative 3, which is just positive 1/3. Or keep it as a fraction because it's slope. This gives me negative 1 over negative 3, which is positive 1/3. So those are the same as well. So then what I want to say is opposite sides are parallel. Therefore, I'm going to abbreviate parallelogram. We're always going to call it a p-gram. So opposite sides are parallel. Therefore, this is in fact a parallelogram. And I use slope to determine that. Alright, I can check to see if a parallelogram is in fact if a quadrilateral is a parallelogram another way, which is by using the distance formula. So what you should be thinking is how can me knowing the distance or the lengths of the segments help me determine its parallelogram? Well, one of the properties says that opposite sides are congruent. So if I can determine if the opposite sides are congruent, then my figure is a parallelogram. So I'm actually going to start just like before, and I'm going to draw a figure that I'm going to show what my sides would be. So here's figure ABCD. What I want to know is, are opposite sides congruent? So the last one I want to know parallel because I was talking about slope, whereas this one I want to know opposite sides congruent because I'm talking about distance formula. So what I want to know is segment AB congruent to segment DC. Is segment AD congruent to segment BC? Okay, so I'm going to go find those distances. So AB equals BC equals AD equals and BC equals. And we go find all of those side lengths. Okay. AB would be the first two coordinates. Remember, to do distance, remember we subtract our x's and y's. So my x's are 2 and 2. So 2 minus 2 squared plus my y's are 5 and negative 7. So 5 minus negative 7 squared. Square root of all that. And I'm going to leave that and go to the next one. DC, erase this so you guys can see what I'm doing. DC would be this coordinate and this coordinate. So my x's are 8 and 6. 8 minus 6 squared. My y's are negative 4 and 8. So negative 4 minus 8 squared. Square root of all of that. Okay. My next one is segment AD. Here's A. Here's D. So my x's are 2 and 6. So 2 minus 6 squared plus my y's are 5 and 8. So 5 minus 8 squared. Square root of all that. Alright, last one. BC, so these two coordinates. So it really helps to identify the coordinates and make your job a little bit quicker. So my x's are 2 and 8, and 2 minus 8 squared. Plus y's are negative 7 and negative 4, so negative 7 minus negative 4 squared, square root. Okay, so now take your calculators and find all of those lengths. You can pause this and then find those and then check it. Okay, this one should be the square root of 144, and again, I'm going to leave it as a square root, just because I don't need the decimal. In that case, it's not, but I don't need the decimals if I don't. It's not going to help me. This one should be the square root of 148. This one should be the square root of 25. This one should be the square root of 45. Alright, well, these two are not the same, and these two are not the same. All I needed to show is that the first two weren't the same, but I mean, I found all of them. So, opposite sides not congruent, therefore not p-gram. Okay, we use the distance formula to show that opposite sides aren't congruent, therefore it's not a parallelogram. Alright, last one. Okay. This is probably the hardest one. Midpoint formula is not as straightforward, so it's pretty hard to understand what it's asking. So again, if I have a parallelogram ABCD, I'm going to draw it. Here's A, here's B, here's C, here's D. So how can midpoint formula prove to us that this is a parallelogram, or disprove that this isn't a parallelogram? Well, don't draw any of this, but knowing this midpoint, and this midpoint, and this midpoint, and this midpoint is not going to help us. That doesn't help us prove anything in terms of is this or is it not a parallelogram. But what midpoint does help us with is the property about diagonals bisecting each other. If I can find that diagonal's midpoint and this diagonal's midpoint, their midpoints are the same because they intersect and they bisect one another. So specifically because they bisect one another, that midpoint would have to be the exact same. And it's a midpoint because if it's bisected, their middles are the same. Okay, so I'm going to call this point E, but really what I'm trying to determine is do diagonals bisect each other? Okay, and the way that I determine that is finding the midpoint of both of my diagonals. Well, one of these diagonals, so I want to find the midpoint of AC. I want to find the midpoint of DB. And if they're the same, then they must have bisected each other. And if they're not the same, then they must not have bisected each other. Okay? So midpoint, remember, is averaging the x's and the y's. So for AC, I add up my x's, so 3 plus negative 12 divided by 2. Add up my y's, negative 1 plus 3 divided by 2. Okay. And then I want to find my other midpoint of my diagonal, which is DB. So this one and this one. So my x's are 0, negative 9. So 0 plus negative 9 divided by 2. And my y's are 3 plus negative 1 divided by 2. Alright, so 3 plus negative 12 is negative 9. Half of negative 9 is negative 4.5. Negative 1 plus 3 is 2. Half of 2 is 1. So that's my midpoint of that diagonal. 0 plus negative 9 is negative 9. Half of that is negative 4.5. 3 plus negative 1 is 2. Half of 2 is 1. So these are the same, which means the diagonals did bisect one another. Or actually, it's easier for you to say each other. Did bisect each other. Therefore, this is a parallelogram. Alright, so your homework, show the sub that you got this done, and then you can pick up your homework. Your homework is worksheet number 1. You're going to go through and you're going to do one of each of what we just ended with. So you're going to use slope to determine whether the given vertices form a parallelogram. You're going to use the distance formula to determine whether the given figure is a parallelogram. And you're going to use the midpoint formula. So just look off your notes to try to figure out what's going on. Okay? You should be able to model that. And then on the back side, you're going to fill in all those statements like your notes. You're going to find the perimeter like your notes. You're going to find the perimeter like your notes. You're going to have to use in both 5 and 6 the Pythagorean theorem, which is saying that if you have a right triangle, that if you have 2 legs and a hypotenuse, you can find any of the side lengths. Okay, meaning like if I were to say that this is 10 and this is 3, I could find this leg by doing 3 squared plus b squared equals 10 squared. But I have to make sure I always set it equal to the hypotenuse. Okay? Alright, we'll see you on Monday.